Disseminate, the computer science research podcast, the DuckDB in Research series.
Hello and welcome to another episode of our DuckDB in Research series. In today's episode, we're going to be talking about database extensibility with Abigale Kim. Abigail is a PhD student at the University of Wisconsin-Madison, and specifically, we're going to be talking about a paper that's due to be published at VLDB. If is that correct? Is it being published?
Yes, VLDB 2025.
Yeah, so depending on when you listen to this podcast, it may be pre-VLDB, it may be post-VLDB, but either way, yeah, VLDB 2025. And the paper is titled Anarchy in the Database, a Survey and Evaluation of Database Management System Extensibility. So yes, welcome to the show, Abigail.
Oh, hello. I'm very excited to be on the show.
Cool. Nice. The first question we always start off with, and that's for you to tell us a little bit more about your story and how you got involved in databases. So yeah, take it away, Abigail. How did you get stuck into databases?
Ooh, that's like a fun question. I was actually so I got into computer science in high school, and then I applied to CMU, actually not because I was interested in systems in any capacity, but because I wanted to be a machine learning or AI person. Like, I was really into the AI hype of the 2015 to 2018 thing. I don't know, the first GPT or something. It's probably something about what I wrote my essay on. And when I got to CMU, I took the concepts of AI class for freshmen and I hated it. I dropped out in 3 weeks. So I was super confused for after that. I was like, oh, wait, the thing that I like, turns out I actually don't like it, So then I kind of hopped around a bunch of different fields. I was an HCI researcher briefly. I delved into web dev, and then I took our intro systems class, and I really, really loved it. And so that was holy grail moment. I was like, oh, I'm going to do systems. I love systems. And what do you do when you like systems? You kind of look at the classes offered at CMU, and I saw that Andy's advanced databases class was offered, and I read the website and it said take operating systems before you take our class, and I wanted to take this class. So I just told my advisor at the time, and academic advisor, and I said, oh, can I please take operating systems? And he said, yes, go for it, even if it's a really, really difficult class, and I was only a sophomore. And that kind of brings me a little bit closer to databases, but really how I met Andy Pablo was I was doing homework for this class outside of his office when he approached with his dog. And I really love dogs, so I asked Andy, can I pet your dog? And he said yes, but I didn't know he was Andy. I didn't put two and two together. And he said, what are you doing? And I said, I'm doing operating systems homework. And he said, oh, what year are you in? I said, I'm a sophomore. He said, you're a sophomore in our really super hard operating systems class. Join my research group. So I joined, and I've just been there since sophomore year, and I really love databases. I have no intention to leave. But at this point, I really like databases because it's a systems problem, and I love solving systems problems, but it's almost sunk cost fallacy. I've been here for so long that if I were to pivot to another systems field, it would just take so long to get all the knowledge I have doing databases. So this is how I ended up here.
Fantastic. So we've got Andy's dog to thank then.
Yeah, it's the motto of the story is if you see professors with cute dogs, you should just ask to pet it. And the dog is
fantastic. That's great. Cool. So let's switch our focus onto extensibility then. So let's set some context to start off with, some background, and then kind of the motivation behind your paper. So tell us what extensibility in the context of a DBMS is and why it can be really powerful, but also quite dangerous as well.
So extensibility in a database context is essentially custom code that you can add new features to a database while maintaining its functionality and infrastructure. So say you have a database system and it has a bunch of code and you want to add a function or add a type, that would be a good use case for using extensibility. But you still keep all of the core functionalities of the database system. You're just or you still keep most of them, as we'll figure out later when I talk about the taxonomy. But extensibility is quite powerful because it gives database developers the tools to create a lot of different features for a database system, which is kind of nice. A lot of the kind of cool projects we've seen recently are database extensions. Like some that come to mind that maybe have hit Hacker News are like PG vectors, like they're doing a lot of vector database stuff, but like instead of writing a vector database from scratch, they're actually implementing it on top of Postgres, so it's useful with Postgres' API. However, extensions can be really dangerous because they can lead to unexpected errors or compatibility issues with other extensions, which is like basically what my paper discusses. And if you run extensions like with other extensions, so this is like the first thing that I noticed when I was doing paper, you can cause the DBMS to produce incorrect results or have corrupt data or even crash. And additionally, there's like insufficient APIs, insufficient infrastructure, and this can also cause extension developers to resort to kind of unoptimal ways of developing extensions, such as like copying code, like literally copy pasting code from the source, or exploiting existing APIs for uses other than their intentions.
Yeah, cool. Yeah, you teased a few things there, and the listener will be hopefully picked up on that. There's going to be a taxonomy, so let's talk about the paper then and the elevator pitch, and yeah, give us the TLDR then on Anarchy and the database. What were you trying to achieve with the paper, and what have we got to look forward to discuss in the next hour or so?
Okay, so the TLDR and Anarchy database, I saw this question, I thought, like, well, TLDR, you should read the paper, but TLDR is the first review. Like, Anarchy database is the first review of the extensibility ecosystem in the modern age. Or really, it kind of just, like, people have been doing this stuff in industry for a hot sec, like, you know, developing extensions really hardcore. There have been, like, multiple industry conferences on extensions, but, like, the research community has not really thought about database extensions at all. So this is like a review of extensibility, but from like a research perspective, I would say.
Very nice. Yeah, it's interesting. I wonder why the research community has not looked at it before. But it's good for you because you've come along and been the first to do it, Abigail. So yeah, great for you. So yeah, when you were doing this survey, then you built a taxonomy, right? So can you walk us through your taxonomy and how you approached characterizing this whole space of extensibility in the DBMS world?
Okay, so I would say in terms of how I built the taxonomy, it was a lot of it started out by looking at what existing databases supported, as I think a good taxonomy should. But in the end, it kind of became like taking a bigger picture, like more vision-oriented focus at like a few things. For example, what existing extensions consist of, i.e. like what components they use to design their systems, not necessarily like what does this extension, like what kind of extensibility features does the database have, like offer to extensions, but also just like what are extensions trying to do? And in line with that, like what kind of code is used to write an extension? Like what is the point of the code used to write an extension? Like are they setting up the features? Like are they setting up features for users? Are they like, you know, is this where they kind of have to write some boilerplate to hook into the existing database system? There's also like an angle of infrastructure. Like what kind of infrastructure does the extensibility ecosystem support? And what kind of infrastructure should an extensibility ecosystem support, but doesn't? And then like developers have to kind of come up with their own workarounds or solutions for it.
Nice, cool. So let's run through the taxonomy then part by part then, Abigail. So and then we're going to see where DuckDB fits into this taxonomy when we get to the end of it. So yeah, there's a few different steps to it. So yeah, give us the breakdown of the various areas of extensibility in some more detail with some examples.
Okay, so like the taxonomy consists of essentially like 6 different, I guess, categories or areas. And the first that we determined was the types of extensibility. So types of extensibility we define as like, I guess like what extensibility features does the database system offer to users? Like you can create this kind of extension. So we identified, I think if I can count in my head, 1, 2, 3, 4, 5, 6, 7, 8 types, and they are like user-defined types, UDTs, functions, client authentication, which is essentially modifying client authentication, utility commands, which is like modifying administrative commands, but not necessarily like core database execution, parser modifications, query processing, storage managers, and index access methods, which are essentially like creating new indexes on top of existing storage. So when DuckDB actually like supports many of these. Out of our 8 types, DuckDB supports 6, all except utility commands and client authentication. In particular, there's a few features of DuckDB that are really interesting. Like, for example, their recent paper, Runtime Extensible Parsers, essentially shows that DuckDB modified its parser to be extensible at runtime without the need of adding UDFs, or changes of parser syntax, which is really convenient because in Postgres, a lot of UDFs are actually used to provide interfaces to their lower level features. Like, I think if you look at Timescale, which is a time series database, its documentation, you'll find that there's a lot of UDFs that really could be like parser statements had Postgres allowed developers to augment its parser. And so, yeah, I think DuckDB does like a pretty good job of these. DuckDB also has an interesting query optimization extension. They have an optimizer extension, which essentially allows you to write your own optimizer passes. And lastly, I think another interesting part of DuckDB's extensibility type support is their vectorized UDFs, which essentially means that like instead of UDFs kind of being like, I think my former lab mate Sam Arch talks about this quite in depth, but UDFs are kind of infamous for being super slow, and DuckDB's vectorized UDFs essentially mean that each invocation of a UDF processes a batch of data, which makes it faster. The next part of my taxonomy is
Sorry, Abigail, let's jump in real quickly there. Sorry, maybe if we can run through each one by one. So, like, on that, so how does DuckDB then compare to these 5 other systems? I think, if I'm correct, if I can count that you compared, that you also fit into your taxonomy. How does DuckDB compare to those? And are there? You said it's got 6 out of the 8. Does it need the other 2, or like what's the trade-off there with like, okay, or it's doing the best it can do, or can it do better, or yeah?
So I think that could DuckDB do better? I think honestly honestly, DuckDB is probably the best. Like, I would say, like, if
Correct
I had to pick an extensibility system, oh my god. If I had to pick an extensibility system that was like doing extensibility like the most like canonically correct way, as of now, I would pick DuckDB over Postgres. It's a hard pick because Postgres is like really the starter of extensibility. Postgres is like it started the extensibility movement. It's like the reason that everybody cares about extensibility is Postgres. Everybody views Postgres as the de facto extensibility database. And like the extensions created through Postgres' API, some of them are really, really incredible. But I would say I would give DuckDB the slight edge, mostly because their extensibility ecosystem is a good portion safer. Like, I think function hooks in Postgres are a mistake, and by that I mean essentially Postgres' extensibility. The way you implement stuff inside a database is that there's a function hook, there's a global function hook variable, and then you set your function hook variable equal to like a function that you wrote, and then you just like shove it into the database, and then extensions invoke each other, which is a big mess at points. And I've even found bugs in existing extensions because they did not call previous extensions in their implementations. But so that's why I would say like DuckDB's extension ecosystem kind of edges out Postgres. But at the same time, well, if any Postgres people are listening, it's okay. You guys are great.
You're still doing great. Yeah. You're still doing better than MariaDB, MySQL, and Redis. So yeah, go you guys.
Oh yeah, no. Oh my god. But yeah, I think I kind of tangented there. But yeah, I think DuckDB is doing like as it goes on. I think they should. I would be not surprised if they didn't add more extensibility. Like the runtime extensible parsers are like a recent development, like a CIDR 2025 paper, and they seem to like have a great focus on extensions and extensibility. They seem to care about it. So I'd be really surprised if they didn't add more features. But yeah.
Nice. Yeah. Cool. So let's move on to the next category in your taxonomy then, Abigail, and that was interfaces.
Oh, yes. So interfaces. I mean, honestly, we've identified 2 interfaces within database systems in terms of how developers integrate their extensions into the system. So there's 2 ways of doing this. One, you can add a component. A DBMS can really just provide a way to add new components via handler functions. And so this would be like, you don't actually change the code of the system at all. It's more like you write a handler and then the DBMS, like you register it and then the database invokes it. Versus the other way of interfacing with extensions is where extensions can actually override parts of the database system code. So in the code, this would be like the database would invoke the extension it like essentially replaces the code in a database system, which is kind of interesting. And actually DuckDB in particular does not have any like way of overriding the existing code. Instead, extensions are registered and invoked. So I think this also contributes to like the overall safety of DuckDB, but
Yeah, nice. Cool. So yeah, interfaces ticked off. Let's chat more about state modification then.
Yes. The next part of my taxonomy considers the state types that extensions can modify. So really, like, extensions can modify 4 different kinds of state. And these are database state, system state, extension state, and ephemeral state. And database state is like the database contents. System state is the internal state of the database system. Extension state is like more persistent data that extensions keep for themselves. And ephemeral state is just intermediate state that it modify, but it doesn't persist in the database.
Nice. Where are we with DuckDB on this then relative to the other systems as well?
Yes. DuckDB actually does allow its extensions to modify its system state. Like, for example, the way the optimizer extension is like invoked in the database system allows extensions to modify its optimizer state. Additionally, extensions can also like add ephemeral state to its implementation. And they can create tables and store state, but like we haven't really seen like extensions really like putting in storing lots of state in a database system in the way that like some Postgres extensions are literally built by like extensions creating their own tables. So, but I honestly think part of this is just the fact that DuckDB is an embedded database system. So embedded in memory. So it's just made to not use that many resources, so the extensions would follow suit.
Yeah, sure, makes sense. So let's chat about some protection mechanisms then. Maybe we mentioned security a second ago about not allowing in the DuckDB context overriding of components, and that's probably a bit safer. But yes, let's tell us about protection mechanisms, Abigail.
Yes. Oh, so protection mechanisms. I think the things that were mainly discussed as protection mechanisms were 1, isolation, and 2, security. So isolation essentially means that how do we ensure that extensions don't interfere with each other? And really, like, the first thing that we discovered, like, that kind of led to this research project is that in Postgres, when you load 2 extensions together, they break. And so within the context of that's kind of where we were like, oh, DBMS extensions are not isolated from one another. And then the other way the like kind of we can discuss protection mechanisms is in a security perspective. So like this would be like, how can people attack the database through like writing an extension and loading it? And so what we found within DuckDB is that DuckDB is actually pretty good at like preventing exploits, especially with their community and core extension repos, because they cryptographically sign their core extensions and their community repo extensions. And on the other hand, I do think that there is a possibility. I think we'll get to this later when I talk about the extension analysis framework, but the APIs in DuckDB can prevent extensions from overriding each other explicitly in the way that Postgres does not allow, but they can also, they do have access to the same state, which could cause problems, but
Nice, cool. So we've got two more categories, Abigail, and the first one of those is system components. So walk us through system components.
Yeah, so system components within my taxonomy means that, what are the components the database provides to the users to help them implement extensions. So these would be things like background workers or additional memory. And in terms of DuckDB, we found that DuckDB's memory management for extensions is really just like C++, modern C++ memory management. So smart pointers, and really just they don't really have a custom extension memory declaration library in the way that Postgres does, mostly because it's a in-process database instead of per thread process model. But they do add data structures. Extensions can add data structures, and they can also extend classes to store additional data. Additionally, we found with locks within a database, DuckDB's extensions just use conventional C++ mutexes. And so I feel like DuckDB's system component support is just once again, the extensions are kind of just following suit of the database system, because this is how the database system manages memory and allocates extra workers and such. But I think that I don't think that these things are these system components are really directly oh, here is an extension API. It's more that just people are seeing what's available in the database and using it as such, but they're using it correctly, which is fine.
Yeah, cool. And last one, developer ecosystem.
Oh boy. Oh my god. DuckDB, developer ecosystem. Developer ecosystem as a taxonomy category is what kinds of building tooling, test tooling, infrastructure is given to extensions. And DuckDB tops every single other extension by extension ecosystem by a large threshold. They have an extension template that has all the build and test tooling that people can just fork and create their own extensions with on GitHub. They have an extension repo with core extensions and community extensions and a list of them. You can install these extensions without any pain. Literally you can just say include extensions from community and then just download the extension. It's just super easy. Although honestly, I think part of this is if you see how Postgres does things and you're oh, I would love to redo that but make it better, it's easy to do, I guess. Right? Because I think Postgres has Postgres's infra is very hit or miss. I think, and they also have unit tests for extensions, DuckDB, but Postgres has unit tests for extensions, and Postgres has a build tooling for their extensions, but it's very imperfect, and I think DuckDB has kind of pinpointed all the errors and made the extensions development experience super easy and convenient.
Yeah, it's look what those guys did. Look at the mistakes they did, and let's learn from those mistakes and make it better for when we do it. So it's good to see that.
Yes.
For sure. Cool. So we're at the end of the taxonomy now. So if you're going to summarize and you're going to kind of compare all the different systems that we looked at, what would you say that these systems mainly get right, what they get wrong, with obviously with a DuckDB focus, given here we're chatting about DuckDB primarily. Yes. But yeah, what would be your summary of your taxonomy and when you put these systems in this various different categories?
Ooh, if I wanted to kind of summarize, I would say Postgres is a very flexible but unsafe API, and I think DuckDB kind of falls in the middle. It's offering a good portion of features, although not as flexible as Postgres, because you can't rewrite the whole execution engine in DuckDB, but you can in Postgres. But I think at the much heightened safety and overall a better extension development ecosystem than basically all the other databases. I haven't talked about much other than DuckDB and Postgres in this podcast so far, but I think I should go a little bit into the other databases I looked at, MySQL, MariaDB, SQLite, and Redis. Like, while I think, for example, like compared to DuckDB, I would say like MySQL has I think the saving grace of MySQL and MariaDB's extensibility is their storage engine API, which like has created many like cool storage engines over the course of time. Versus, for example, InnoDB is actually like an extension, which is awesome. But MySQL's documentation is super, super like sparse for their extensibility, and same with MariaDB. In fact, I ran into something recently. Online, it says that MariaDB does not support UDTs. If you Google it, there's no documentation. But if you go to the MariaDB server code base and you look at the plugins folder, you'll see that there are extensions that are like flagged as data types, and in fact do support additional data types in the ecosystem. So you get really confused. You're like, this is a data type extension, but online it says no data type extension support. So like that's how
isn't it? Like I can see it here, I don't see it there. Like what's going on? Yeah.
Put as a yes. Like we put it yes in our paper because we saw them in the code base, and you see them in the code base, you have to put yes. But like it's like something that's actually come up. People are like, oh no, MariaDB doesn't support UDPs. I'm like, if you look, they do. But yeah.
Just forgot to advertise it.
Yeah, exactly. As terms of SQLite doesn't have that much extensibility. SQLite's the other embedded database, so I would be very surprised if people didn't compare SQLite and DuckDB a whole ton. Like, they probably do. But I think SQLite just doesn't have the same extensibility support, or even, like, the same amount of, like, want for people to implement extensions on top of it. Versus, like, I think at least the other databases are pretty clear. And Redis, oh boy. Redis extension support used to be incredible until the whole politics thing happened, and then I was like, okay, that was a whole thing. But basically Redis changed their license and then like got rid of its module documentation. It was like when I started this research project, Redis hadn't done the whole rebranding of it to be like a cloud SaaS product. So the module documentation was incredible. There was a whole list of modules on the website. They clearly wanted people to contribute. And instead, their revamp made it get rid of its module documentation. And now it's like marketing itself as like a service instead, which is a bit devastating. But Redis doesn't have that. Redis's support is really interesting just because it only supports commands, which are essentially UDFs. But these UDFs can access the Redis key value store. And you could use them to build on top of the DB ecosystem. So they had some really interesting extensions, like, for example, Redis Graph, which is a graph database implemented on top of Redis. They created like an entire like SQL execution engine on top of Redis, which is awesome. But I wonder if Redis is still like championing these extensions or championing these modules, because I have not found a documentation on their website except from the Wayback Machine.
Yeah, no, that's a shame. That's a shame when that happens.
I know.
When business interests take over, right? Let's frame it that way.
Yeah.
Cool. So yeah, no, that's a really, really nice summary there, Abigail, of all of the various different systems and what they choose to do and what they choose not to do. So, I think the next thing we should talk about is you've mentioned it a few times now, and this is your extension analyzer that you ran on Postgres, and this is where you found that sometimes when you run two extensions together, bad things happen.
Yes.
So let's talk more about that. And yeah, give us the rundown on your extension analysis and the toolkit you made to answer those questions.
Okay. So the toolkit is actually the starter of my research. So I'm very excited to talk about it. But the toolkit originally was like a smoke test on Postgres extensions. And so essentially what we did was we took two Postgres extensions, we ran their units, we compiled them, we put them together, we ran their unit tests, and we saw what broke. And then we discovered that a whole bunch of things broke, which was really fun. Like, for example, like things that broke. This is section 5.4 of the paper which I remember very well because this is like probably the fun part of it. But we found like that configuration settings caused it to broke. We found like extension bugs like that were only triggered when you ran extensions with like with an extension with some other extension. We found like user-defined operator compatibilities. So basically, like Postgres will misinterpret user-defined operators for several extensions. And then when their function signatures don't match the DBMS's API, it'll just error out. And we also found that some extensions want to be installed first or last, partially because they override like a bunch of state in their hook implementations. But this is a DuckDB podcast, so I should talk a little bit about DuckDB because originally we only ran the extension compatibility framework on Postgres, and then we submitted the paper to VLDB. And because that's the largest ecosystem by far, there's like over 400 extensions in Postgres, and DuckDB is still quite new. But then the reviewer said, why haven't you implemented an extension framework for the other databases? And this led me to a very interesting adventure in fall 2024 when I was doing the revision. So basically, like we hypothesized that DuckDB extensions could conflict in a similar way to Postgres because they share state. But when we ran the analysis thing, like we did the exact same thing with DuckDB extensions, we found that these claims did not come to fruition, which is really interesting. First, part of the reason is DuckDB has too few extensions with these state sharing interfaces. The majority of DuckDB extensions in their core and community repos currently are like they're UDFs, and UDFs don't really conflict with one another because they're just like running their own code on top of other things, like in top of the existing database. And really, like when we ran this extension stuff, and I think it's more now, but only 4 of 45 extensions in DuckDB's core and community repos use to optimize their extension interface. Second, because the code base uses modern C++ paradigms, it's just much less likely to have memory management errors. And so, like, I think only really, I would say that the takeaway should be that Postgres has a more volatile extension ecosystem because the state sharing is like a lot more complicated in Postgres extensions so far. And it's also significantly easier to make programming errors in C compared to C++, especially in terms of memory. And lastly, I think that just the fact that Postgres extensions are responsible for running other extensions causes like a whole host of problems versus in DuckDB, all the extensions are invoked by the database itself.
Nice, cool. You said there that, so first of all, great news for DuckDB, right, from those findings. The thing that jumps out is, do you think it is possible still, given the way DuckDB is at the moment, to sort of, like, at some point in the future, it will also have the same problems that Postgres? If you could sort of go in there, manually handcraft some extension to create one of the bad situations where an error arises, do you think that would be possible if you wanted to get really sort of, really stress test the framework and go, okay, well, I'm going to put these two extensions together that I know I've made evil, basically, and they're going to interact together and cause a problem. Would that be possible?
Oh, I absolutely could, because I could implement, because like even if you just look at the optimizer framework, like it takes in the Postgres, like the DuckDB optimizer, and then an implement, like it just, like it changes it. So I could create extension 1 that like takes the optimizer and just like applies this trick, and then I could apply extension 2 that like undoes this trick and like, and then I would end up with the same state of the DuckDB optimizer, and then I would just like run it, and it would be like, when you run extension 1, this optimizer state works as intended, and when you run extension 2, it like gets undone and it gets like reverted to its original state. And so that should be possible. That is like, I wonder, like, I think in some sense, any extension framework that changes state like this is like, it creates this kind of inevitable problem. I think like, if I were to go to the future, I think it would be really cool if you could create something like a static analysis kind of framework that would identify these problems like before. Yeah, that'd be really cool. That'd be really nice to have some sort of tool and some sort of verification there to make sure you're not inadvertently introducing such a problem. But that's a nice segue there, talking about the future, about
Where do you go next with extensibility research, and Abigail? What's next on the agenda?
Yeah, there's not that much research work in extensibility, even if it's like honestly a really big deal in industry. And like, to be honest, the paper has gotten like a lot of unexpected positive attention, from the podcast, from like I was offered to give like a keynote, CDMS, so that's something to look forward to. I was offered to give a lightning talk at like the DuckDB meetup in London at VLDB, which I will also do. And I think this is largely why, like, people are just like, oh, like, research people are like, wow, this was a problem. And Postgres people are like, wow, someone is finally doing the research on this important topic that devs don't really have time to address. In terms of extensibility research, what's next? I think this static analysis tool, like, probably a lot of, like, PL stuff, honestly. Like, kind of, like, horror triples, like, software feature engineering kind of PL stuff, not, like, the super theory-heavy PL, but I like this idea because I think that it would be really useful to people, because I think the state sharing is inevitable. Like, the state sharing is what truly causes most of the problems at a deep core. It's like the sharing of like some sort of like state or execution or operations, like, and so to figure out where these kinds of things overlap when you load to extensions could be like a really interesting project. I also think that extensibility has exposed a lot of like kind of interesting research questions, especially in the composability space. So, for example, like people are creating extensions for some kind of use case, like, I don't know, like Citus, distributed Postgres. Like, what if there was a way to create extensions that were like perfectly safe and flexible, like perfectly safe, but like you were able to do this in a way that like guaranteed safety and flexibility? Like, if you look at my evaluation like graph that evaluates the safety versus flexibility trade-off, we'll notice that most of the databases fall within like they're kind of not safe but flexible, or they are safe but they are not flexible. And like the ideal would be to find database system that hits the sweet spot.
Yeah, for sure. We need to be striving for that. I know the listener can't see the image, but we want the upper right quadrant on this plot, right? That's where we want to be. We want to be safe and flexible.
Yes.
That's the ideal place to be. But cool. It sounds like there's a lot of really interesting directions for research there, Abigail. So yeah, I look forward to seeing what comes out of it over the coming years. My next question was going to be about impacts, and you touched on it a little bit there about sort of what impacts your work has had. You said it sort of generated a lot of interest from people. Could you maybe elaborate on that a little bit more, on like kind of what any sort of like kind of explicit examples of feedback you've had from people in the community, and then also as well, like have you had any conversations with people at DuckDB, and has it had any influence on the way they are thinking about their extension framework going forward?
So, like, it's too early, honestly, to see, like, oh, my work, like, influenced some database system to do
Test of Time Award, yeah.
To do extensibility. Oh, no, oh my God. I sure hope so. That would be incredible. But, so, like, I won't expect it to impact, like, explicitly, oh, this code was influenced, like, if Postgres finally implements an extension manager or something like that. I'm not going to see that until a few years later. But I gave a talk on it on my work at the Postgres Development Conference in 2024. And I was shocked because I thought like, oh, like I'm kind of a beginner here. Like I'm just like, I did this as a master's thesis and I think I know like a good portion about it, but you guys are like the experts, right? Like they've been doing Postgres for 20 years or something. And everyone, like so many people loved my talk. They actually loved it. Like I got shouted out on like several blogs. I got like, what's it called? Shout outs on Twitter. People were like telling me all sorts of incredible things. Like they were like, oh, whatever you like, your talk has influenced like whatever we do next in the Postgres extension ecosystem. And I was like, oh my goodness, this is like the best compliment I've ever received in my whole life. And so like, I think that so far its impact is mainly just people-based, which I think is like the start of creating this is the start of like real change within the database ecosystem, which I really appreciate and also hope will happen, like, I hope that people will kind of understand, like, within impact, like, I hope the research community understands, like, extensions are important and useful and worth researching because they're relevant to industry, and also because they are really good research prototype tools as well. And I hope the industry community kind of, like, takes some ideas from my paper and is like, oh, maybe it would be a good idea if we prioritized like these things. But I think a lot of the things in my paper, the Postgres community already realizes. Like, I'm almost some sort of reporter for the Postgres extension community. They're like, oh, we already know, like, 90% of these issues. And this is just like something that's coming to light through this paper.
Yeah, you kind of collating them all together and kind of making them visible, right? Which is good. You've been the champion for the issues. That's great. Cool. I just got a couple more questions now, Abigail. The first one is about surprises. And whilst working on extensibility, has there been anything that sort of jumped out? I was like, wow, did not expect that.
I did not expect so many problems to come from smoke testing. I thought that the smoke testing was like the smoke testing happened quite early in the extension research. The taxonomy was actually developed after the smoke testing, which is like the reverse order in the paper, but like this is like actually how it went. And I did not expect them all to break. Andy expected them to break, but I did not. I thought they were gonna, like, it was just gonna be fine. Like, we're literally just running these unit tests. Like, how bad could it get? But it was really bad. So I was like, oh, why are there so many problems? And then I was like, that was very exciting for me. That was one surprise. There were a few there's like many surprises. Honestly, most days were a surprise in some capacity. Like, you're always
that's
finding
good though.
something.
Keeps it interesting, right?
Yeah, exactly.
Yeah, that's awesome.
Yes.
Cool. Yeah, so can't speak. Penultimate question, Abigail, and that is, I always like to finish off sort of here with a DuckDB recommendation. So, of all of the cool things that DuckDB does and has, what's your favorite plugin, extension, or feature?
Oh boy, haha! This is almost a trick question. I am like almost obligated to say the current DuckDB extension I'm working on during my PhD, which is Series DB. GPU accelerated DuckDB. You should give it a try. It's open source. And so that
great
one's
plug.
fun.
We'll put a link to that in the show notes, Abigail. So
you gotta put it in the show notes.
Play with it as well.
Yeah. Like, everyone should try out this extension. It's awesome. It's like, it actually is awesome because like we've gotten DuckDB to be so fast. It's like incredibly fast. And I think DuckDB is like nice extensibility framework. It's implemented as a table function, which is essentially like you can call from like, it's kind of like you can call it from the from statement of a SQL clause. That's how it's implemented currently, and it's like an entire execution engine layer implemented on top of DuckDB, which is awesome. So I think that's gotta be my favorite extension so far. But if I had to offer some other extensions that I think like some cool tech within the DuckDB extension ecosystem, I think the way that the scanners are implemented, like the Postgres scanner, SQLite scanner, is pretty cool. Like, they basically like override all the core classes in DuckDB, like in a database. Like they override the catalog and like call it the Postgres catalog, and then just like kind of connect to a Postgres database within DuckDB. And I think that's pretty cool. So, yeah.
Yeah, nice. Some good suggestions there for the listener. Great. We're on to the last word now, Abigail. What's the one thing you want the listener to get from this podcast today?
I would say one thing that listeners should take away from this podcast is, I think they should it depends on where you are. If you're in the research community and you're listening to this podcast, I would say you should check out the extensibility ecosystem in general, because I think that like it's cool. There's a whole minefield of problems, and it's like very useful. Like, even if you're not going to do like extensions for your PhD or something, like, it's a really useful tool to just kind of like learn. And I think not a lot of people, even in the database community, are pretty like aware of extensions. And it's only recently that they're starting to gain traction, especially with the whole composable system stuff that's going on. If you are in the industry community, I'm sure that you probably like the database industry, like the database industry people they've interacted with in general tend to know a little bit more about extensions, or at least they know of the existence of them. But if they, I don't know, I would say thank you. But that's not really a takeaway. Thank you. If you work in the database extension community and you're in industry, thank you, because the work you're doing is pretty cool and I admire it. But that's not a takeaway. Okay, I'm struggling with the takeaway. Maybe it's like read research.
Go play with. I would say go play with your GPU extension.
Oh yeah, maybe that's a solid takeaway, but maybe it's just like that. Yeah. That's a takeaway, but more of shameless plug.
Self-promotion is fine. Don't worry.
Oh my god.
Cool. We'll wrap things up there then, Abigail. But it's been a really nice chat. Thank you very much. I'm sure the listener will have really enjoyed it as well. Where can we find you on social media? Are you on any of the various platforms?
I am Abigale Kim on Twitter, because I refuse to call it X. I am also, I'm Abigail Kim on most things. I am Abigail Kim on Blue Sky. I do have a website which has like a blog, but like the blog is super unupdated. And I think those are the 3 places you can find me the best. Yeah, really.
Cool. Well, we'll stick those in the show notes as well. And yeah, thank you very much again, Abigail. It's been a lovely chat.
Thank you.